Next test we can use is called the second derivative test. Second derivative test means all you need to do is to differentiate it one more time to find out what is the value of d2y dx squared. Okay, so in essence, when d2y dx squared is greater than 0, it is a minimum point. If it's less than 0, it is a maximum point. The limitation is if it is equals to 0, it cannot determine what kind of stationary point is it. So you have to use the first derivative test. So some students like to just use the first derivative test. I would say that if the function is easy to differentiate, then let's use the second derivative test. Something like this example. Y is equals to 2x plus 8 bracket x minus 1 power negative 1, because I bring it up. My dy dx is going to be 2 minus 8 bracket x minus 1 power negative 2. Make this nice first, so that the next step when you do for stationary point, my dy dx is going to be equals to 0. Okay, always bring the fraction to the right side. 2 equals to 8 over x minus 1 square. Do not open the x minus 1 square. Just multiply this up. 2x minus 1 square equals to 8. And then the 2 bring down. X minus 1 square equals to 4. We will have my two answers. X minus 1 equals to plus minus square root 4. So x minus 1 is equals to 2, or x minus 1 is equals to negative 2. X equals to 3, or x equals to negative 1. Next thing is, because they ask for coordinates, we should sub it into the y. Y is equals to 2 times 3 plus 8 over 3 minus 1. Okay, sub it into your y, 2 bracket 3. Okay, so that's 6 plus 4, and that is 10. Y equals to 2 times minus negative 1 plus 8 over negative 1 minus 1 square. Sorry, there's no square. Okay, and this is going to be negative 2, negative 6. Okay, so your coordinates are 2 comma 10, sorry, 3 comma 10, as well as negative 1 comma negative 6. Now, how to determine the nature of these stationary points? I need to use my second derivative test. Let me write down what is my dy dx first. Dy dx is equals to 2 minus 8 open bracket x minus 1 power negative 2. Okay, that is from this part over here. Okay, so now I need to differentiate it again. Second derivative, d2y over dx square is equals to power bring down 16 x minus 1 power negative 3, which is equals to 16 over x minus 1 cube. Sub in the first value, x equals to negative 1. My second derivative, d2y dx square, is equals to 16 over minus 1 cube. And that would give me negative 2, which is lesser than 0. And these are the exact steps that you should present. Okay, d2y dx squared equals to what? Greater than 0 or lesser than 0. In this case, it's lesser than 0. So hence, negative 1 comma 6 is a maximum point. When d2y dx squared less than 0, it is a maximum point. Same thing, I sub in x equals to 3. My d2y over dx squared is equals to 16 over 3 minus 1 squared. That would give me equals to 2, which is greater than 0. Okay, so therefore 3 comma 10 is a minimum point. And that is how you use the second derivative test, okay, to find the nature of the stationary points.